Hi guys, welcome back to my channel Space Exploration. Today in this video I am talking about nebulas. So let's get started. First of all I will tell you what really is a nebula, how does they form, and after all what does they do. First of all let's see what are the types of nebulas. There is 5 types of nebulas we know so far. Their names are 1. Planetary nebulae, 2. Emission nebulae, 3. Reflection nebulae, 4. Dark nebulae and 5. Supernova remnants. Okay, so first of all let's talk about basics of nebulae. Nebulae is an interstellar region of spacetime, made by giant clouds of dust and particles. Also nebulas are mainly responsible to create stars. And commonly they're created by dying stars such as supernova, kilonova, nova, etc. So let's talk about nebulas by their types. 1. Planetary nebula. All planetary nebulas are formed at the end of the life, by a star of intermediate mass, about 1 to 8 solar masses. It is expected that the Sun will form a planetary nebula at the end of its life cycle. The smallest planetary nebula we know is NGC 7207, which is elliptically shaped, having diameter of 0.1 light-years to 0.2 light-years. Also this nebula is not just smallest planetary nebulae, but it is smallest any type nebulae. The biggest planetary nebulae we know is the Helix Nebulae, also known as NGC 7293, having diameter of 5.74 light-years. Also some scientists says that the Helix Nebulae is a limit for an intermediate mass star to create. Means they think creating bigger planetary nebulae than the Helix Nebulae is almost impossible for an intermediate mass star. 2. Emission nebulae. An emission nebula is a nebula, which is formed of ionized gases, that emits light of various wavelengths. The most common source of ionization is high-energy, ultraviolet photons emitted from a nearby hot star. Among the several different types of emission nebulae are H2 regions, in which star formation is taking place and young stars are the source of the ionizing photons, and planetary nebulae, in which a dying star has thrown off its outer layers, with the exposed hot core then ionizing them. The smallest emission nebulae is also NGC 7027. And the largest emission nebulae is not just largest emission nebulae, but is one of the largest nebulae. It is N44, roughly 1000 light-years in diameter. 3. Reflection nebula. In astronomy, reflection nebulae are clouds of interstellar dust, which might reflect the light of a nearby star or stars. The energy from the nearby stars is insufficient to ionize the gas of the nebula to create an emission nebula, but is enough to give sufficient scattering to make the dust visible. The Great Orion Nebulae is one of the most famous reflection nebulae, which is roughly 24 light-years in diameter. 4. Dark nebulae. A dark nebulae or absorption nebulae is a type of interstellar cloud that is so dense that it obscures the visible wavelengths of light from objects behind it, such as background stars and emission or reflection nebulae. The extinction of the light is caused by interstellar dust grains, located in the coldest, densest parts of molecular clouds. The Horsehead Nebula, silhouetted against a bright, H2 region, is the most famous example of a dark nebula, which is roughly 7 light-years in the diameter. At last, but not least, supernova remnant. A supernova remnant is the structure resulting from the explosion of a star in a supernova. The supernova remnant is bounded by an expanding shock wave, and consists of ejected material, expanding from the explosion, and the interstellar material it sweeps up and shocks along the way. The resulting supernova explosion expels much or all of the stellar material, with velocities as much as 10% the speed of light, or approximately 30,000 kilometers per second. These speeds are highly supersonic, so a strong shock wave forms ahead of the ejection. That heats the upstream plasma, up to temperatures well above millions of kelvins. The shock continuously slows down over time as it sweeps up the ambient medium, but it can expand over hundreds or thousands of years, and over tens of parsecs, before its speed falls below the local sound speed. The most famous supernova remnant is Crab Nebula, which is roughly 11 light-years in diameter. Thanks for watching this video. I hope you enjoyed the video. If you gained even little knowledge from this video, like the video and consider subscribing the Space Exploration channel. Thanks for watching.